My name is Vilmos Steinman from Utrecht Lorraine University, and so my thesis is a little bit out of the terrestrial things. I'm working on the Mars, and I try to estimate hypothetic formation time of a Martian network. Our analyzed valley is close to the Martian equator. It can be found next to the Pallas crater and Tinto valleys. The average length of this valley is 81 kilometers. The average depth is 250 meters, and the average width of this valley is a little bit less than 2 kilometers. There are many problems how to represent valley shapes. But I am lucky because there are very good images from the Mars, especially with the CTX, or so-called convex camera, can make a 6 meter per pixel resolution image from the Martian surface. And in these images is very good visible. The valley has a trapezoidal shape, not the normally V-shaped. So for the time estimation, I made 100 points for the top left and right side of the valley and the bank sides of the valley, so which is called the down left and right, and also the Thalweg area. And I use not the former determined shear stress and sediment diameter values, so for the Mars. So I calculated these values from the TEMIS TI, or so-called thermal emission imaging system thermal inertia values. These values can can be represent different sediment diameters, and these sediment diameters can be calculated as shear stress or non-dimensional shear stress, so-called shield stress. So each 100 points give an Euclidean distance, so I can represent the average width of these sections, and these sections made another average what I use for the whole estimation. So in the upper left image, so we can see the slope, and the left upper, the curvature image. These two map was a help to estimate the top left and right, and the bank and the Thalweg area of the valley. The left down image represents the small scale of a valley, so we can see the exact trapezoidal shape, and the right down image represented with a point, with a measure point. And here is the results of my hypothetical estimation. I measured from 1 meter to 50 meters, and I calculated maximum depth, the water depth. I calculated the flow and the sediment discharges too. During the calculation, I used the Martian gravities and the calculated average shield stress, shear stress, and sediment size. In my hypothesis, every water depth represents the same sediment thickness, and I calculated the formation time. So how many time need to erode this? So for example, 50 meter water erode a 50 meter thick sediment. So if I calculate without the cavity volume, it's a little bit less than 400 years, especially 595 years. And with the cavity volume, this number is a little bit less than 500 years. Yes, and I made a crater-based age estimation across the valley, and this 1 meter water depth represents the best between the difference between the two craters. I go a little bit back, I'm sorry about it, from the source or source craters down in the middle of the left image, and the final or deposition crater in the north. The exact time between these formations of the craters, it's a little bit less than 5,000 years. So this method can be represented very good the whole formation time of this valley. There are many fail in this method, I know it. So in the future, I try to calculate to each section a different timeline and try to figure it out the morphological time of this valley with a good resolution. But I have some problems with the volume calculation. It's not so easy because the trapezoidal shape. And I am thank you for your attention. I am waiting your questions.